So today I'll be talking with you about a pretty entry-level presentation about backups and incremental backups specifically. It's an enhancement I've been working on for the past couple of months. My name is Shelly. I'm a senior software engineer in Red Hat. I've been contributing to KubeVirt for almost 5 years. And let's begin. As I mentioned, today I'll be talking with you about backups. I'll be talking about our existing KubeVirt protection solutions. Why do they fall short? Why do we need incremental backups? What are incremental backups? What do we gain from incremental backups? And I will show you the API that I'm working on implementing, the new CRDs that I will be adding, the controllers, and the whole pipeline that will be added to the project. So, backups. Protection of our current KubeVirt VMs. What do we have currently? So for your quick short-term solution, we have our KubeVirt VM snapshots. This is like a great way to do undo if you did like a small issue, an update that you didn't want to do or you're regretting to do. You can use the VM snapshots that we have, which use volume snapshot as a method of doing this process. Now, if you need something a bit safer, a bit, you wanted to have your data safe in a remote location for any disaster that may come, you have your full backups. Full backups also work relying on the CSI storage that you have, working with volume snapshots. But this time you're not keeping it as a volume snapshot right next to your storage. You're taking the volume snapshot and you're moving along the data to your offsite location. Now, that works great, but it's a bit problematic if you're working with on scale, right? If you're having a lot of data and you keep changing stuff, and you're adding more data, and you have a lot of VMs and you want to back up everyone. So what's the problem basically? So the first one is, yes, you have storage dependency. So in most cases, and usually also if you work in scale, you will have a good storage with a good CSI driver with good capabilities, and that's great. But it's also possible that you don't have a very fancy storage and you just want to back up your storage without any dependency if the storage has volume snapshots or not. And now the most significant issue with full backups is that even if you have just changed some minimal amount of data and you're doing a full backup, you're still backing up the same amount of data. You have a terabyte of data and you only change 1 gigabyte out of that data, you will still back up the entire tera. Once you have the full data that you need to back up, you also need to, if you want it to be safe elsewhere, you need to move it. If you need to move it, you're using your network, which again, if you have scale and a lot of data and a lot of storage, that consumes a lot of your resources in the cluster. So the solution. So I've been working on incremental backups and more specifically, storage-agnostic incremental backups. Let's break it down. Incremental backup, as I mentioned, instead of every time that you're backing up, do a full backup of your entire data, you will be making the first full backup of your entire data, and the next backup that you will be making will be only the data that has been changed from that previous backup that you've made. For example, in the illustration that you have at the bottom of the page, the full backup was 10 gigabytes, and then another one incremental backup that you made was for 1 giga, and then the second one was half a giga, and the third one was another 1 giga. And that's the only data that you're backing up and moving along, instead of having each time 10 gigabytes to move. Now, storage agnostic means that we are doing the backup without relying on your CSI storage. We will be using our native VM hypervisor backup capabilities that already exist using libroot and QEMU backup functionalities. So, what do we gain? The most significant thing, obviously, is your smaller backup sizes. You're using less storage. You don't need to move along as much data as in full backups. You're not relying on your CSI storage capabilities. You can have any storage, and you don't need to have any specific storage, or you can have your local cluster that you're running and run with it. Once you have smaller data that you need to back up, the time for each backup shrinks, meaning you can do much more backups as long as, as much as you want. And as mentioned again, the network traffic and the fact that it is VM native makes it more natural to our KubeVirt VMs. Okay, so I'll be explaining a bit of definitions. We talked about incremental backups and what do they mean. Now, how do we track the changes that have been made? Are with this definition of changed block tracking, or in short, CBT. It's a way of tracking which data blocks have been written ever since your previous backup, and that will be done with a dirty bitmap that will be turned on if this specific block has been changed, knowing that we need to back it up. In order to do all of that, you need the capabilities of CBT. Now, in KubeVirt, we are running VMs with raw data, with raw images, which doesn't have this capability. So in order to gain this capability, we will be adding to the VM QCO2 overlay. What does it mean? We'll be adding a lightweight file that will be shared over the disk, and that will give you all the capabilities of QCO2, specifically the CBT, and will only store the essential data, meaning you're not touching the data, you're not affecting your raw disk at all. And as easy as you can apply it, you can also remove it. It doesn't affect your disk. And it doesn't require more space than the disk. It's only a couple of megas to only keep the metadata. And lastly, what is a checkpoint? That is more like an API meaning term that I'll be using. That's how you will call that point in time. When you take the backup, you will create a checkpoint that since this time. You will be tracking the changes. And when you will want to do a next backup, it will look at the previous checkpoint that was created in the previous backup, look at the QEMU dirty bitmap that was that's corresponding to this specific checkpoint, and will be used in order to calculate the size of the backup, the incremental backup that you need to do. Okay, so we're getting a bit more technical and a bit more less theoretical. So in order to enable CBT, as I mentioned, you need the QCO2 overlay. We need to put this small QCO2 overlay inside a PVC. So your virtual machine will have your PVC that has your root disk. And next to your VM, we will be adding a VM state PVC. You might already know this term because it's also used up for other stuff such as TPM data. So right next to it, we will putting the overlay QCO2 image. And And in order to apply it, this will not be applied automatically. We have decided to add some configuration to decide which VMs will be added to this VM state PVC, because still VM state PVC has its own drawbacks, which is also being worked on. So in your KubeVirt configuration, you can add the change block tracking label selector, and then you can decide which namespaces you want to be included and have the possibility of doing backups, or you want specific virtual machines that have specific labels, or if you just want to put it all out there, you can just mark this virtual machine selector as an empty, and then it will select all the VMs, and all the VMs that match this selector will get this VM state PVC and get this QEMU overlay that will enable you the option to use and to do incremental backups. Okay, another small issue that I want to close up before I'm getting to the API is how will you use or how will you get the data? So this is also completely KubeVirt term. When you're doing a backup, you have a push mode and a pull mode. Push mode, as it sounds, the data, the backup output, will be just pushed directly into a provided PVC. This PVC will be provided at the start of the backup process. It will be attached to the VM. It will get the backup output and be detached again. And then you will get the output of the backup process will be a QEMU sparse image inside this PVC. Now regarding pull mode, this means that we will expose a network endpoint that you will be able to pull directly the data out over the network into whatever location you are pulling the data from. As a first phase, and the design will currently, and that this presentation will currently explain, is the implementation of push mode. Okay, so let's start with the CRDs. The first CRD will be virtual machine backup, as easy as it sounds. Virtual machine backup, name, namespace, and pretty simple spec. You can decide which mode you want to do the backup. As said, push is currently the default and the only option. And you can also not mention it because that's the default. And the PVC name, the PVC that you provide that you want to get the output of the backup to. And the source, the VM that you want to do the backup for. And in the status, you will get what type of backup did you made. The first time will obviously be full. Now, this will always get you a full backup, this specific form of virtual machine backup CR. And that's not why we're here. We want incremental backups. In order to do that, we need to track in a way the checkpoint that we made in order to know when you provide and you ask for the next backup, from which point in time you want to do it. For that, we have the virtual machine backup tracker. It's also a pretty simple CRD that basically has the source of which VM you're going to do the tracking for. Now let's apply both and see what happens. So you have the tracker, you're doing a backup for your VM. And in the virtual machine backup, you will, instead of referencing the source, the VM that you want to do the backup for, you will reference the backup tracker with the name of the backup tracker. As a result, another small thing you can see in the status, that instead of just getting what backup type you got, you will also see the checkpoint name. That's just for, showing that the backup succeeded and you get the checkpoint name back. But this checkpoint name will also be updated in the tracker. In the status of the tracker, you will see the latest checkpoint with the name, the creation time, and the disk that were participating in the incremental backup. And now if you apply the same virtual machine backup CR, basically you can leave it with the same name, the same backup tracker name, even the same PVC. If you have created a large enough PVC to contain all the backups that you want, you can also use the same PVC. And now if you apply this CR, you eventually will see that the status has changed with the new checkpoint name of this new backup that you have created. And this time the backup will be incremental, meaning that only the changes that have been done since the latest checkpoint have been saved and being pushed into the PVC that you have provided. So that's basically the CRDs that you need to know. And the pipeline might seem pretty straightforward. You will apply the CR that I just presented, the virtual machine backup, in order to initiate a backup. This will be received or monitored by a controller, Invirt controller, that will find your PVC, the target PVC for the backup. It will attach it to the Virt launcher in order to have the access from libvirt to push the data to. Then it will pass along the backup request through the Virt handler to the Virt launcher as any standard request that you have in the system. There, the request will pass along to libvirt. That will push the data out to your PVC. And eventually, when the backup will see that show that it was over, the controller will detach the PVC, and then there you have it, the PVC with the output of the backup that you wanted. Now, one thing you might have noticed that I have not mentioned is, okay, so I got the backup. What am I doing with it? So this feature enhancement is giving you the backup output to a PVC. And from there, you do need to decide how you are working with this output. This feature is most likely will be consumed by different backup providers, different backup solutions that you have out there that will initiate themselves the backup and will get the output and move it along to their backup storage, and will also probably automate the way that you are putting and restoring a VM from that. I have mentioned here the most naive way of handling the backup output, which is basically you get this QCO2 sparsed files. You have the full first backup and the rest of the incremental backups according to the to your different backups that you did along the way. You will need to merge them sequentially according to the order of the backup that was made, in a way that you will eventually get a full QCO2 image until the point of time from which you want to restore. Then with this image, you will need to upload it to a PVC. You can use, for example, image upload. And with this PVC, you will use it to put a VM from that PVC. And there you have it, a restored VM with the backup. And everything is ready to go. And lastly, you will be glad to know that the work is currently in progress, and I will appreciate any reviews for PR that I will be publishing. So if you want to join the effort, you're welcome to do it. And as mentioned, for our future work, and the design is open and not settled yet. So also, if you want to share your thoughts about how we can do pull mode, a VEP will be uploaded to the enhancement repo, as Andrew mentioned. And also offline backup, which, as you saw, the whole process depends on libvirt. And if the VM is shut down, libvirt does not exist. So we need to think of a nice way to do that. And a small limitation that I'm mentioning is that when you want to enable CBT, you have to restart the VM, because this is currently a limitation by LibVirt, and there is an open RFE to fix that. And that's basically it. I think I'm right on time. Also, I don't know if I have time for questions or if you had questions along the way.
We'll have to move questions into the Q&A. I think you've got a couple there already. Thank you very much, Shelly. We'll have to shift quite quickly onto Howard's talk, an introduction on CCA on ARM, I believe.
Okay. Thank you for listening. I appreciate it.
Thank you, Shelly.